Good morning. This is open source software and hardware DET 3107 elective 1. Course outcomes. To have an introductory knowledge of concept of open and free software and hardware, introduction of Arduino software, Arduino hardware, Raspberry Pi, Internet of the Things IoT. To get an in-depth knowledge of Arduino software IDE, simple programs, interfacing of basic hardware modules with Arduino. To acquire knowledge of interfacing and programming of Arduino for ADC, DC motor, Servo Motor, Bluetooth, Zigbee, Wi-Fi and PWM programming. To understand the details regarding LaTeX software with its installation, programming, processing, software facilities useful for various document preparation. To understand details regarding Scilab software with its installation, programming, processing, console, editor, graphics window, software facilities useful for various technical calculations. To study TCAD as an electronic computer-aided design, TCAD tool for designing circuit schematic, electric rule checking, netlist generation, mapping, components and designing PCB. So we have discussed the Arduino digital output and the rotation, controlling the rotation of DC motor. Rotation of DC motor, controlling of rotation of DC motor, and this is the DC motor which we see in this particular photograph, which is having the positive and negative connections. We connect the voltage there, positive to positive, negative is ground connection, and it will have one directional rotation. But if you reverse the connections, that two previous connections, that is positive to positive and negative to zero ground connection, we connect positive to the ground connection and negative to the positive connection. Then there will be opposite rotation of the motor. So this we have seen. Then reversing the connection, positive, negative, reversing the polarity reverses the direction of rotation of the motor, and changing the voltage will change the speed of the motor in both the cases, in both the directions. If you change the voltage in both the directions, speed of the motor changes. And this is the software to control or to rotate the motor. So this is Arduino digital output, rotation controlling of DC motor. Code of rotation or no rotation. Code of either rotation or no rotation. It will start the rotation or it will stop the rotation. And this is used on pin number 13 and ground. Pin number 13 is used. And digital signal is used. Digital write is used for making the motor rotation on and off. Pin number 13 is the digital pin. It is not PWM pin. So it is digital write. So while setup is there, setup curly brace, opening, setup curly brace, closing. In between that, pin mode is there. 13 number pin is defined as output pin. So pin mode 13 output. It specifies the Arduino pin number and the output input mode, that is direction. So this is pin mode, which is used in the setup for setting the pin mode of the pin 13. Then while loop is there. That while loop will have the opening brace and closing brace. In between that, there will be the program for the while loop. There are 1, 2, 3, 4 instructions. First is the digital write 13 high. So 13 number pin is outputted high logic or high voltage or 1 logic. So this turn on pin number 13 sending a high signal. Then there is a delay of 1000 1000 millisecond delay is there, that is 1 second delay is there. Wait for 1 second. Comment is wait for 1 second. Then there is a digital write again, 13 low. 13 number pin initially was high. That 13 number pin now is made low. Digital write 13 low. This turns off the 13 number sending a low signal. There is a delay of 3000 milliseconds, that is 3 seconds. Wait for 3 seconds. So whenever the pin is made high, it is wait for 1 second, and whenever pin is made low, it is wait for 3 seconds. Last one. So digital write is the command for which the pin number and direction, pin number and output is given, whether output is high or low. The digital write is a command which use the details of which pin is to be operated and what is the output. So pin number 13 on which the output is sent, and the type of output either high or low can be sent. The digital write 13 comma high will give the pin number 13, make the pin number 13 high, or it will send logic 1, or it will tie plus 5 volt to the pin number 13. Pin number 13 will give logic 1 or plus 5 volt. Then there is a delay of 1000 milliseconds, that is 1 second. It will wait 1 second, that means the 13 number pin is tied high for 1 second. It will give output high or 5 volt for 1 second. Then there is a digital write 13 low. So 13 number pin is made low, so it will give 0 volt. And this continuous delay 3000, that is 3 seconds. So 3 seconds it will give low signal, 0 signal. Then again after delay 3000 it will again go to digital write 13 high. So it is a while loop. So digital logic 13 high 5 volt for 1 second, and it goes low for 3 seconds. Again it goes high 1 second, it goes low for 3 seconds, and it continues. So like that. So this will be the waveform for the motor, and accordingly 25% duty cycle is provided, and accordingly the DC motor will rotate. If we change the delay, the speed of the motor will change because it will become PWM. The average voltage will increase, that is duty cycle will increase. From 25% it will become something else. So out of 4 seconds, 1 second is output high and 3 second output is low. In this way motor rotates. During that 3 seconds output is low, but due to some inertia motor may rotate for some time. Okay. And continuous rotation is obtained if the delay are very small. Okay. So on and off time are very small, then it may rotate continuously. So this is the software with which we can control the motor operation, turning on and off of the motor is there, and there are delays. So this is the motor operating, digital motor operating software, which either turns on the motor or turns off the motor. Okay. Similarly, there is another program which is having the digital output rotation, again controlling the DC motor. And in this program, there is Arduino digital output rotation controlling DC motor. Connect, it is pin number 13 and 12. 12 and 13 two pins are used. In previous case, the ground is used and 13 number pin is used. Motor is connected to 13 number pin on one side, and it is connected, motor's other side is connected to ground. So only one directional rotation is possible in that case. Only single direction rotation. because polarity change is not possible. Polarity changing is not possible in this case. So if there is a 13 number pin, so this is IC, this is 13 number pin, and from 13 number pin motor is connected. So this is motor, and other terminal is connected to ground. So whenever there is a positive or high or logic 1, okay, or plus 5 volt on pin, then motor rotates in particular direction, say clockwise direction. Okay. And when it is 0, no rotation of the motor is there because both sides it is grounding. So this is the logic in this case. In next case, the two terminals of the motor are connected to two different pins of the Arduino. Two terminals are connected to two different pins of the Arduino. So pin number 13 and pin number 12 are used. Pin number 13 and pin number 12 are used. So while setup is there, curly brace opening of the setup, curly brace closing of the setup is there, and in between these two there is a setup instructions. There are two instructions now, pin mode and pin mode again. Two pin modes are there. For different pins we have to set differently the mode of the pin. So pin mode 13 is there, which is the output flow pin. Again pin mode 12 is there, which is also output pin. So both the 13 and 12 are output pin. So this specify Arduino pin number and output input mode. Okay, both these. So now two pins are defined. 12 number, 13 number, both are output. Both are digital. Then wide loop is there. This is the curly brace opening of the loop and this is the curly brace closing of the loop, and in between whatever the instructions are there, those instructions will be executed for infinite time, continuous execution. First instruction, second, third, fourth, fifth, sixth instruction is executed. Again first is executed, second, third, fourth, fifth, sixth is executed. After sixth again it goes to first, and this continues unless and until we reset the board or we power off the board. We disconnect the power supply to the board. What are the 6 instructions in the under the while loop? Are digital write 13 number high, digital write on 13 number high, and digital write on 12 number low. So there are two pins. One is 13 number and one is 12 number. And to these two pins, motor is connected. Okay. Motor is connected in between 13 and 12. And in first case, 13 is made high, plus 5, and 12 is made 0 volt. So in this case, suppose motor rotates in this direction, clockwise direction. Then there is a delay of 1 second, delay 1000, that is delay of 1 second. 1000 millisecond means 1 second, delay of 1 second. So turn the pin number 13 sending high signal, turn on the pin 13, make pin 12 as a ground. Send 0 or low on the pin 12, so make pin 12 as a ground. The 13 number is acting as a 5 volt high signal and 12 number is acting as a 0 volt or ground signal. So current will flow from 13 to 12 to motor, and motor will suppose rotate in this clockwise direction. Then this will continue for 1 second, 1000 milliseconds. After 1 second, digital write 13 is made low. Now 13 is made low, 0 volt. Make the pin number 13 a ground pin. Okay. And there is a digital write 12 high. So now 12 is made high. So 12 is offering plus 5 volt to the motor. So previously 13 is plus 5, 12 is 0. Now 13 is 0 and 12 is plus 5. So direction of rotation will be opposite to previous, anti-clockwise. Suppose if previously it was clockwise, then now it will be anti-clockwise. If previously was anti-clockwise, now it will be clockwise. Just opposite to previous. So digital write 13 is low, digital write for 12 is high, making 13 number pin a ground, and turn on pin number 12, sending high signal. Again delay is there for 3000 milliseconds, and that is wait for 3 seconds. Same program is there, previous program, just two additional instructions are there, digital write 12 low and digital write 12 high. So these are the two additional instructions, making once the pin number 12 ground and other time the pin number 12 as a high signal pin. Now motor rotates in for 1 second in one direction and for next 3 seconds in opposite direction. Again 1 second in one direction and again 3 seconds in opposite direction. And this is the direction control of motor. This is the direction control of DC motor. So with the help of software, we can control the direction of DC motor. No additional hardware is required. You can do it with the hardware also, but this is with the purely with the software. So if required, buffer may be there in between, and this is just the logic. We are discussing here just the logic. So we are showing that the motor is directly connected to pin number 13 or pin number 12 or both pin number 13 and 12. But if motor requires higher currents than the port currents, port maximum current, maximum port current, then there will be motor driving ICs. There will be motor driving circuits in between. And those are called buffers. Buffer may be required to connect. This is just logic that we are connecting motor one terminal to 13, another terminal to 12. In previous case also we are connecting motor terminal to the 13 and other terminal to the ground. But buffer may be required in these cases. If two pins are there, both buffers are required. Okay, or both amplifiers are required, or both driver circuits are required. So in this way, with the help of software, we can either turn on and turn off the rotation of the motor only in one direction, and in some more improved program, suppose we can rotate the motor in one direction or other direction by using two pins instead of single pin of the Arduino and modifying some sort of programming instructions or program. We can convert the on-off of the motor in one direction, single direction. Now we can use the motor in both the directions, and we can have the on-off also, or we can have the continuous running also in both the cases. In this case also, we can turn on motor for some time, then we can turn off the motor, then we can turn the on motor in opposite direction, and again we can turn off the motor. This is also possible. Or rotate in one direction, rotate in other direction, rotate in one direction, rotate in other direction. That is also possible. All the possibilities are there. Okay. So this is one more example, which is somewhat improved program for the DC motor. So this is all about the DC motor. We have discussed the DC motor details, or in general motor details, in the previous lecture, and that detail where we are having the coil placed in the magnetic field, and that coil is allowed to pass through current, or current is sent through the coil, or electricity is applied to the coil placed in magnetic field, fixed magnetic field. Then that coil will get exerted a force. This is motoring action. This is motoring action. The direction of the current and exerted force and magnetism we can have by left hand rule. Similarly for the generator it is by right hand rule. Isn't it? These rules are there. And we can apply the rules and we can find out in which direction the rotation will be there. If we know the magnetism direction, if you know the current direction, you can find out the direction of force exerted on the coil. So this is the motoring action we have seen. And then there are variety of the various types of the motors in DC motor only. Various capacity of the motors, very heavy capacity, high capacity motors are also there, and very low capacity motors are also there. Moderate capacity motors are also there. So these motors, according to capacity, require different electrical power. And we know, according to the specification, our microcontroller will provide some amount of electric power. We will check this power or voltage or electric current, maximum, minimum for the port pins with the data manual of Arduino microcontroller 328. Okay. So accordingly we find 40 milliampere current is there, but if motor requires higher current, then we have to connect the buffer ICs or motor driver ICs. Those ICs are amplifying the signal current from the pin. Those buffers will keep the voltages same, but current they will boost. That means the power amplification will be there in out. And then the DC motor can be interfaced to the microcontroller through buffer or through motor driver circuit or through amplifier circuit, and then the motor can be controlled. Motor is controlled in both two ways. DC motor can be controlled in two ways. One control is controlling the direction in which motor is rotating. The rotation direction of the motor can be controlled either clockwise rotated or anti-clockwise rotated. That is possible to control by changing the polarity of the connection to the motor. Positive and ground, positive and negative of the supply to the motor can be controlling the direction of the motor. If one setup is there, for one pin, for one connection of the motor positive is connected, other connection negative is connected, then in one, suppose one direction motor is rotating, if you reverse that polarity of the motor connection, motor will start rotating in the opposite direction. This is the polarity and direction of rotation of the motor. And the second thing is speed of the motor can be controlled by controlling the electrical power or voltage, you can say. So we change the voltage, applied voltage to the motor, it changes the speed of the motor. And this speed of the motor variation can be possible in both the directions. If in one direction we have connected the configuration and connected the wires, then if you slowly, gradually change the voltage, accordingly the speed of the rotation in that direction changes. Either if you increase the voltage, speed of the rotation of the motor increases. If you decrease the voltage, speed of the rotation of the motor decreases in that particular direction. Now if you change the polarity, make it opposite, the opposite directional rotation of the motor is possible and is there. And again in this case, if you change the voltage, then the speed of the motor will go on changing. Okay. If you change the voltage of the applied voltage to the motor in any of the combination of the direction of rotation, then according to voltage increases, speed of the motor rotation increases. If voltage decreases, rotation speed of the motor decreases. So these are the two things. One is rotation of the motor, speed of the motor can be controlled, and direction of rotation of the motor can be controlled. And this control can be done with the microcontroller, Arduino. In both the cases, control can be done with the Arduino, and we can use either analog as well as digital pins and digital and analog instructions. And we can control both these things with the help of software also, software only. No hardware changes are required. We can control it with the software, because we have seen 12 number, 30 number pin are connected to two connections of the motor, and we can send 1 to the 12 and 0 to the 13, or 1 to the 13 and 0 to the 12. And that will change the direction of rotation, and we can change the delays on-off periods that can be changing the average voltage of the pulse, and that's why it can have the variable speed also, that you can check actually with the help of Arduino kit, software uploader, and connecting motor. You can have the motor also. It is up to 50 to 100 rupees price motor. So this is about the DC motor. This is the DC motor. Then this is the simple program for the DC motor. One pin connection to the DC motor. So only DC motor on off can be achieved, or even speed control can be achieved, but in one direction. Both direction control is also achieved with this another program. Then there is a Arduino digital output motion control for servo motor. This is for servo motor. Previously it was DC motor, now it is servo motor. Servo motors are electronic devices that convert digital signal to rotational movement. It converts the digital signal to rotational movement. So how the servo motor works? There are two types of the servo motors. One is standard servo and second is continuous rotation servo. Standard servo and continuous rotation servo. In standard servo, their rotation is limited to maximum 180 degrees in either direction, each direction. Suppose this is the motor and this is the reference of the motor. It can rotate in this direction 180 degree and in this direction 180 degree, and it can cover 360 degree by rotating in opposite direction. So continuously it is not rotating in same direction for full 360 degree. So it will rotate in one direction for 180 and again come back to original position. It will rotate in opposite direction for 180 degree. So this is possible. So this is standard servo. The continuous rotation servo will continuously rotate in single direction to complete one turn, second turn and third turn. In opposite direction also it will complete one turn, second turn, third turn. So continuous rotation servo that can provide rotational unlimitedly. It is not only the 180 degree or something. It is unlimitedly. And in both direction also. Unlimited and in both directions. Okay, 1 minute, I will take the call from mobile. So let us continue. Two types of the servo motors are there: standard servo and continuous rotation servo. In standard servo, the rotation is limited to 180 degree. Continuous rotation servo, there is no limitation. Unlimited rotation is there in both the directions. So this is the operation of the servo motor. There are three connections on the servo motors. As you see in the photograph also, there are three connections, three wires. One is ground, second is VS, third is digital. One is ground, second is VCC or V5 or VS, 5 volt, ground volt, and digital pin. As the digital pin is controlling the rotation. Ground and VCC, they are providing the power supply, or ground and 5 volt, they are providing the power supply, and the digital pin is providing the control of rotation for the servo motor. Okay. So if you consider the Arduino digital output motion of the servo motor, okay. Arduino digital output motion of servo motor, then a servo motor is a motor that pulses at certain rate, moving its gear at certain angle. Okay, it pulses at certain rate. One pulse is given, second is given, third is given. It pulses at certain rate for every pulse. Okay, for every pulse it turns for certain angle, maybe 1.8, maybe 3 degree or something. For every pulse. So there is a control wire, control connection, and that is digital pin. Okay, that is digital pin. So there will be ground, there will be 5 volt, there will be digital pin. It has 3 connections. One is a black is a ground, red is a connected to 5 volt, and white or yellow in this case is set to digital pin. We are connecting it to digital output, digital pin. So microcontroller or Arduino digital pin is connected to digital pin of the servo, and ground and VCC, they are tied to ground and VCC, high volt and ground. And now this digital pin is controlling the rotation. Okay, these are the connections of the servo motor, as we can see from this figure also. Okay. So this is the photograph you can see for the servo motor, and there is a red and black. Black is a ground and red is a 5 here provided on the Arduino. And this is 0, 1, 2, 3, 4, 5, 6, 7th pin is connected to the digital control pin to the motor. The yellow wire is connected to this. So in this way we can check the connections. You can observe the connections here. Connecting is, the motor is like this. Then there is a software or program, the Arduino standard servo rotation exact angle, how much exact angle it can rotate, that we can check. Okay. It is Arduino standard servo rotation exact angle. So we have to include servo.h, it is a header file. We have to include servo.h. The servo, my servo type of the, create a servo object to control the servo. Create the servo object. Servo is the object type, and my servo is the variable name of the object. Okay. Then there is int POS position equal to 0, a variable to store the servo position. What is the servo position? That is stored in this window, in this variable POS, and it is integer. So this is a declaration, then void setup will be there, and this is the curly brace opening of the void setup, and this is the curly brace closing of the void setup, and within that my servo dot attach equal into bracket 9. My servo dot attach into bracket 9. This attaches the servo on pin number 9 to servo object. This attaches the servo on pin number 9 to servo object. So this is the command or setup initialization. Pin number is given, pin 9, in its bracket my servo dot attach. Now there is a void loop, starts its curly brace here. The closing curly brace for void loop is this, and in between these two curly braces there is a program. So my servo dot attach 9. This is the execution of that function is there. Then for loop is there. That for loop is having POS variable, initialization to 0. POS is checked for 180 degree, less than 180 degree, and POS plus equal to 1. So it is POS plus plus. It is nothing but POS is equal to POS plus 1. POS equal to POS plus 1. This you can write as POS plus equals 1. That means POS equal to POS plus 1. Or you can write POS plus plus. Both these or all these three are same. All these three are one and same. Both these shortcuts are same. POS equal to POS plus 1. Variable equal to variable plus 1. So for loop, POS is initialized to 0, POS is checked for 180 degree and POS is incremented by 1. It goes from 0 degree to 180 degree in steps of 1 degree. And in this for loop, we can have the myServo.write POS and delay of 15 milliseconds. So tell the servo to go to a position in variable POS. Servo will go to the position in to POS. POS is 0 and it will go on increasing 1, 2, 3, 4 up to 180. So it rotates from 0 to 180. Okay, myServo.write position. Delay for each rotation delay will be 15 milliseconds. Wait for 50 milliseconds to servo to reach to the position. The next for is there that pose is 180, pose less greater than or equal to 1, pose minus equal to 1. Pose plus equal to 1 आहे तसं pose minus equal to 1 आहे. POS variable एक नी कमी केला जातो. It is reduces by decreased by 1. So for POS is equal to 180, POS more than or equal to 1, POS is equal to or POS minus 1 or POS minus equal to 1 or POS minus minus, all these three are same. So this is the for loop which changes from 180 to 0. First for loop is changing angle from 0 to 180. Now presently the angle is of servo motor is 180 degree. Then from 180 degree it is changing to 0. So again it is relocating the motor at its original level. Okay. It goes from 182 degree to 0 degree. So this for loop it goes from 180 degree to 0 degree. So for pose 180 semicolon pose more than equal to 1 semicolon pose minus equal to 1 pose minus equal to 1. So what it does, it rotates the servo motor from 180 to 0. Okay. So this is the myServo, opening curly brace, closing curly brace. This is the program for this for loop. myServo.write pose. Again same myServo.write pose and delay 15. Both these are same. Tell the servo to go to position in the variable pose and write 15 milliseconds for servo to reach the position. Wait for 15 milliseconds. So these are the two for loops. One rotates the servo motor in one direction from 0 to 180 and other rotates from 180 to back to 0 in the opposite direction. Okay. So this is the two routines. As there is a myServo attach 9 number, there will be myServo detach. This detaches the servo if you are not controlling it for a while. For a while, if you are not controlling, it detaches that servo, myServo.detach. And you can give any delay, suppose 2000 milliseconds, that is 2 seconds you are detached. Due to the electric, this brake is there for 1 or 2 minutes. So let us start this. myServo, we have attached the first the servo motor with the attached last solenoid. myServo attach is the instruction. myServo attach. myServo.attach. This instruction attaches the servo to pin number 9. Pin number 9 we have given. It will attach the servo. That activates that servo on pin number 9. So for that we have to include the servo.h. We have to include the servo.h. Okay. Servo.h is the header file which is having all the routines of servo motor related instructions and definitions, okay, stored present in that particular header file. So servo attach is starting the servo operation, and servo detach at the last will detach the servo. That detach the servo if you are not controlling for some time. So once the routine is executed from start to end, okay, servo attach is there, and then for position 0 to 180 degree it is rotated, and again from 180 degree to 0 it is rotated, then it can be detached. We can detach it, okay. Then we'll have the delay 2000 millisecond, that is 2 seconds. For 2 seconds there will not be servo operation, and again that after delay that routine again goes to first instruction, my servo dot attach 9. So it is a while loop, it is infinite loop, it is continuous loop. So it runs continuously unless and until we reset the Arduino board, or we power cut the board, or make the power supply off to the board. Okay, in both the cases it is operational. Okay, so yes, पालनेकर बोला काय? अमोल पालनेकर, तुमचा हात रेज झालेला आहे. प्रेझेंटेशन दिसत नाही आहे का? परत एकदा अटॅच करू का? प्रेझेंटेशन आलं का? प्रेझेंटेशन पालनेकर, प्रेझेंटेशन आता दिसतंय? पेलनेकर, अमोल पेलनेकर, ठीक आहे. प्रेझेंटेशन साठी असेल तर यू कॅन म्यूट नाउ. So in this we can see the initially it is my servo attach instruction, and at last it is my servo detach instruction. In between my servo dot attach and my servo dot detach, we have rotated with two different for loops. First for loop rotates from 0 to 180 degree. Each time delay is 15 millisecond. And second for loop rotates 180 degree to 0 degree with again every time delay of 15 millisecond. Okay, once the 0 degree to 180 degree rotation is there, again rotation of 180 degree to 0 degree original position is achieved. Each time there is a 15 millisecond delay in each angle. Okay, 0 degree, 1 degree, 2 degree, 3 degree, every time 15 millisecond delay is there. After this operation, the my servo is detached for 2 seconds. Okay, no operation is there on the my servo at the last but one. शेवटची डिले आहे त्याच्या अगोदरचा डिलेच्या अगोदरची इन्स्ट्रक्शन my servo detach आहे. Okay, so we detach the servo for 2 seconds. Okay, so include the servo is there. This is the header file. Then my servo is declared, object is declared my servo. Okay, and then POS variable is declared, which is given 0, which is integer type. Then void setup is there. In setup, curly brace opening, curly brace closing is there. My servo attach 9 is there, that attaches the servo on pin 9 to the servo object. Okay, the servo object my servo is defined that attaches the pin number 9. Then while loop starts, this is the curly brace opening, my servo dot attach 9 is executed. Then for loop is there. In the for loop pose 0 to less than 180 rotate होतो for loop. प्रत्येक वेळेस my servo dot write होतो pause. तो पोझिशन जी आहे 0 1 2 3 ही राईट होते my servo वर. त्याप्रमाणे my servo त्या अँगलने रोटेट होतो. आता तो 4 डिग्रीला असेल तर 5 राईट केला तर 4 वरून 5 ला जाईल, 5 डिग्रीला असेल तर 6 राईट केलं तर 5 वरून 6 ला जाईल, असं 180 पर्यंत जाईल. प्रत्येक वेळेस डिले 15 आणि पुन्हा एक फॉर लूप आहे तो 180 वरून 0 पर्यंत येईल. ओके, माय सर्वो राईट पोज म्हणजे 180 असेल तो तिथं राईट होईल, 179 राईट होईल तेव्हा परत 1 डिग्रीने रोटेट होईल, 178 असेल त्यावेळेस आणखी एका डिग्रीने रोटेट होईल, असं करत करत 0 डिग्रीला येईल. त्यानंतर माय सर्वो डिटॅच होतो. आता 2 सेकंदासाठी डिटॅच होतो, 2 सेकंदासाठी काम करत नाही. ओके, माय सर्वो डिटॅच किती डिले 2000 मिली सेकंद, तो 2 सेकंदासाठी काम करत नाही. ओके, आणि माय सर्वो डिटॅच झाला की परत तो फर्स्ट इन्स्ट्रक्शनला येतो, माय सर्वो अटॅचला येतो आणि मग पुन्हा पोझिशन 0 to 180 ला रोटेट होतो फॉर लूपनी, पुन्हा दुसऱ्या फॉर लूपनी पोझिशन 180 to 0 ला रोटेट होतो. प्रत्येक वेळेस एका स्टेपला डिले 15 मिली सेकंद घेतो आणि मग माय सर्वो डिटॅच होतो अगेन 2 सेकंदासाठी म्हणजे 2000 मिली सेकंद. हे कंटिन्यू रोटेट होतं. So this is the operation of servo motor. So this is the operation of servo motor. Which servo motor it is? It is standard servo motor. Standard servo motor and continuous servo motor are two servo motors. Standard servo motor rotates in one direction from 0 degree to 180 degree and other direction 0 to 180 degree. So 0 to 180 degree rotation servo motor is there, that is called standard servo motor, and continuous servo motor is a servo motor which rotates in both the direction unlimitedly. It is not limited to 0 to 180 degree, it is rotating unlimited. So the servo motor here we are connected is standard servo motor which rotates in 0 to 180 degree. The controlling the standard servo with again the user input is the program. Again we can check here the program include servo h is there, including of the servo.h file, header file inclusion is there. Okay, then object is defined, that is create a servo object to control a servo. Same things are there, both the things are same. Okay, what are these things? To previous program, same things are observed here on this program also. So servo typeचा my servo object define केला. Then there is a definition of one variable and it is equated to 0 and that is type of integer. Integer type variable is defined and that variable name is POS, position साठी, servo motor position angle साठी तो डिफाइन केलेला आहे. POS नावाचा तो इंटिजर आहे कारण त्याच्यामध्ये इंटिजर व्हॅल्यू असेल 0 1 2 3 4 180 पर्यंत. So this is variable to store the servo position. Then one more is there, integer type of the variable, that is angle value. One more variable, it is 0, equated to 0, angle value. So name is given angle value. Again one more is there, integer is again serial number is also equated to 0. So presently pose, angle value, serial number, all three are equated to 0. So this is the definition. Then void setup will there. In that the curly brace opening and curly brace closing is there. Within that the serial begin is set 9600 and my servo dot attach is connected to 9. So my servo attached to 9 is same as previous program, but here the serial begin is used. Serial communication is used. Serial begin baud rate is given 9600. Serial begin 9600. Serial begin we have discussed previously. So this is same program as the previous program. Two variables are additional. One is angle value and another is serial number. Similarly, there is a serial combination, serial operation. Serial trans receive is there, and for that the baud rate is defined. Serial dot begin 9600. So let us check. This will be the while loop. This is the curly brace opening of the while loop, and this is the curly brace closing of the while loop. Okay. So this will be the total curly brace. Sorry, this will be the total mains loop up to here. So this is the curly brace opening and closing, and this is the program in the loop. So this is the program in the loop. Okay. So this is the code or program in that loop. So this is the code, and this code is in the loop. That's why it will rotate. It will continuously execute. It will execute up to this last instruction, my servo.detach, and again it goes to first instruction in the loop. It will define the value. It will have the serial println. It will check the if, then it will again check the if, and it will execute all these instructions. And at the end, it will execute the my servo.detach, and again goes to first instruction. So first is the integer definition of value. There is one more variable value. So there is an angle value variable which is a global, and this is local within the loop. So value is one more variable. So in this value, serial read is taken. Serial read. Serial read is the receiver input. Okay. And then serial println the value. Whatever the read is there in this value, whatever the stored in this value is there, that is serially println. Serial.println, which printed or displayed into the serial monitor. This is the use of serial monitor. Now we are able to observe the value, the data, the number stored in the value. And what is that number? It is read from serial read. Okay. Now, if value is not equal to -1 and value is not equal to 10, exclamatory marking not. This we have seen in the logical instructions. So exclamatory mark is not equal. So it is not equal to -1 and double ampersand and not equal to 10. हा 10 ही असायला नाही पाहिजे, -1 ही असायला नाही पाहिजे. असं जर असेल, दोन्ही जर कंडिशन सॅटिस्फाय झाल्या, तर देन दिस इफ कर्ली ब्रास ओपनिंग अँड कर्ली ब्रास क्लोज मधला जो इन्स्ट्रक्शन आहे, हा इन्स्ट्रक्शन तो एक्झिक्यूट होईल. ओके. त्याच्यामध्ये काय होईल, हा सिरियल नंबर इक्वल टू सिरियल नंबर इंटू 10 प्लस व्हॅल्यू -48 असं एक्झिक्युशन होईल. कधी होईल, जर ही व्हॅल्यू -1 आणि 10 च्या ऐवजी दुसरी असेल तर, नॉट इक्वल टू -1, नॉट इक्वल टू 10. ओके. देन इट विल एक्झिक्यूट. सिरियल नंबर मध्ये सुरुवातीला काय ठेवलेलं आपण, सिरियल नंबर मध्ये 0 ठेवलेला आहे सुरुवातीला. सिरियल नंबर इक्वल टू 0 इंटू 10 इज 0 प्लस व्हॅल्यू -48, जी काय व्हॅल्यू रीड केली असेल -48 ही सिरियल नंबर मध्ये स्टोअर होईल. नाउ इफ व्हॅल्यू इक्वल्स 10, समजा ती 10 असेल, नॉट इक्वल टू 10 असेल आणि नॉट इक्वल टू 1 असेल तर हे एक्झिक्यूट होणार नाही. आणि समजा ती 10 असेल, व्हॅल्यू इक्वल टू 10, मग हे एक्झिक्यूट होईल. इफ चा कर्ली ब्रास ओपनिंग हा आहे आणि इफ चा कर्ली ब्रास क्लोजिंग हा आहे. ओके. तर ह्या सगळ्या इन्स्ट्रक्शन इफ च्या अंडर येते. एवढ्या सगळ्या इन्स्ट्रक्शन एक्झिक्यूट होते इफ व्हॅल्यू इक्वल टू 10. ओके. आणि व्हॅल्यू कुठून येतं, तर व्हॅल्यू इथं येतं, सिरियल रीड मध्ये येतं. सिरियल रीड मध्ये सिरियली रीड केलं जातं, रिसीव्ह केली असती व्हॅल्यू. ती व्हॅल्यू समजा 10 असेल तर हे सगळे एक्झिक्यूट होईल. माय सर्वो डॉट अटॅच इक्वल टू 9, म्हणजे 9 नंबरला, पिन नंबरला सर्वो मोटर अटॅच होईल. अँगल व्हॅल्यू इक्वल टू सिरियल नंबर मॉड 180. अँगल व्हॅल्यू इक्वल टू सिरियल नंबर मॉड 180. अँगल व्हॅल्यू कसं करता येईल, सिरियल नंबर जो आहे इथं जो स्टोअर झालेला आहे मॉड 180. ओके, त्याचं डिव्हिजन घेऊन त्याचा मॉड काढलेला असेल, फुल नंबर तो असेल, फ्रॅक्शन सोडून दिला जाईल, तर तो अँगल व्हॅल्यू असेल. देन माय सर्वो डॉट राईट अँगल व्हॅल्यू, म्हणजे जो आपल्याला अँगल व्हॅल्यू इथे कॅल्क्युलेट केला तो आपल्याला राईट लिहायला करायला लागेल. माय सर्वो टेल सर्वो टू गो टू पोझिशन इन व्हेरिएबल पोज. इथं आपल्याला कॅल्क्युलेट केलेला अँगल व्हॅल्यू आहे एवढं रोटेट करायला लागेल. त्यानंतर सिरियल प्रिंट एल, मग आपल्याला मॉनिटरवर प्रिंट करायला लागेल. सिरियल प्रिंट नंबर रिसिव्ड फ्रॉम सिरियल पोर्ट. सिरियल पोर्ट वरून आपल्याला जो नंबर रिसिव्ह झाला आहे असा मेसेज आपल्याला प्रिंट करायला लागेल आणि तो नंबर पण प्रिंट करायला लागेल. सिरियल प्रिंट एल सिरियल नंबर, हा सिरियल नंबर जो आहे ना कॅल्क्युलेट केलेला आपण सिरियल नंबर, इथं तो सिरियल नंबर आपण प्रिंट एल करू. प्रिंट एल नुसता प्रिंट म्हणजे प्रिंट करून तिथंच थांबेल. प्रिंट एल म्हणजे प्रिंट करून न्यू लाईनला जाईल. एल एन लाईन न्यू, प्रिंट एल एन लाईन न्यू, न्यू लाईनला जाईल म्हणजे कॅरेज रिटर्न होईल, नवीन लाईनला जाऊन थांबेल. आणि सिरियल नंबर जो काय आपण कॅल्क्युलेट केला होता तो प्रिंट केल्यानंतर सिरियल नंबर इक्वल टू 0 करून टाकेल. तो पुन्हा सिरियल नंबरला 0 करेल आणि डिले घेईल 250 मिली सेकंड, म्हणजे 1/4 सेकंडचा डिले घेईल. हा डिले घेतला की तो पुन्हा इथं जाईल, इंटिजर करेल, व्हॅल्यू करेल, सिरियल रीड करेल. सिरियल रीड म्हणजे रिसिव्हरला जो काही व्हॅल्यू असेल तो आलेला असेल तो रीड करेल, व्हॅल्यू मध्ये स्टोअर करेल आणि तो व्हॅल्यू प्रिंट पण करेल. किती आला व्हॅल्यू प्रिंट करा. मग तो व्हॅल्यू -1 असेल आणि 10 असेल तर ते खाली जे रुटीन आहे ते एक्झिक्यूट होणार नाही. कुठलं रुटीन आहे, कर्ली ब्रास ओपनिंग कर्ली ब्रास क्लोजिंगच्या मध्ये. आणि त्या रुटीन मध्ये एवढं एक इक्वेशन आहे, सिरियल नंबर इक्वल टू सिरियल नंबर इंटू 10 प्लस व्हॅल्यू -48. हे इक्वेशन एक्झिक्यूट होणार नाही. अदर दॅन -1 आणि 10 अशी जर व्हॅल्यू असेल तर ते एक्झिक्यूट होईल, सिरियल नंबर कॅल्क्युलेट होईल. आणि सिरियल नंबर कॅल्क्युलेट होताना सिरियल नंबर इक्वल टू सिरियल नंबर इंटू 10 प्लस व्हॅल्यू -48. ओके, तर तो सिरियल नंबर जुना असेल त्याच्यात 10 ने मल्टिप्लाय होईल आणि प्लस व्हॅल्यू -48 ॲड होईल आणि नवीन सिरियल नंबर येईल. त्याप्रमाणे इफ व्हॅल्यू इक्वल टू 10 असेल तर हे परत एक्झिक्यूट होईल. इफ व्हॅल्यू इक्वल टू 10 नसेल तर हे इफच्या अंडरचं एक्झिक्यूट होणार नाही आणि परत ते इथं येईल आणि परत व्हॅल्यू रीड करेल, असं कंटिन्यू होईल. इन दिस वे there will be servo operation in this case. Okay, so in case of servo operation we have to connect the VCC and ground and digital pin, and this digital pin is now here we are using as 9 number pin. Suppose then we will have my servo attached 9. Okay, in this program also we are using same 9 number pin, and here we are using serial begin 9600 to have the serial transmission reception. So we are reading the serial reception pin number 0, and whatever the value on that pin is there, that is read and stored into variable which is name having value VALUI. So in that variable serial read is stored and it is printed for our information on the monitor, and it is checked value is -1 आहे का 10 आहे. जर दोन्हीही नसेल, नॉट इक्वल टू -1 आणि नॉट इक्वल टू 10 असेल, हे ट्रू झालं दोन्ही पण, म्हणजे -1 पण नाही आणि 10 पण नाही, तर सिरियल नंबर कॅल्क्युलेट झाला, सिरियल नंबर इक्वल टू सिरियल नंबर इंटू 10 प्लस व्हॅल्यू मायनस 48. आणि मग इफ व्हॅल्यू इज 10 असेल, व्हॅल्यू जर 10 असेल तर मग माय सर्व अटॅच होईल, तो अँगल व्हॅल्यू कॅल्क्युलेट होईल आणि मग अँगल व्हॅल्यू राईट केला जाईल आणि नंबर रिसिव्ड फ्रॉम सिरियल पोर्ट किती होता, त्याची व्हॅल्यू, सिरियल नंबर किती कॅल्क्युलेट झाला तो राईट केला जाईल आणि सिरियल नंबर 0 करून टाकला जाईल आणि 120 मिलीसेकंड थांबून पुन्हा रुटीन एक्झिक्यूट होईल, नवीन व्हॅल्यू रीड होईल. दिस इज द ऑपरेशन program for Servo Motor again. So I think we will stop here for today. Thank you. Be at home, be healthy, be safe. So we will continue the lecture of embedded systems on the same link after 1 or 2 minutes. So stay connected. Thank you.